Okay, guys. So today, what you're going to do is you're going to go to this website and we're going to start to think about heat and temperature. So when you did the Google form on walking across hot coals, you got a feel for that the coals may have been hot in terms of the temperature, but there really wasn't a lot of heat there underneath the coals because it was just a thin layer, right? So temperature and heat it's a hard concept to master, but they're not exactly the same thing. And so today, by exploring this website, it's just going to sort of like give you another chance to think about temperature and heat and temperature. We a lot of times we just think of them as the same thing, but in terms of the physics and chemistry, they're slightly different. So let's just kind of explore a little bit more, and then next week we'll get into the quantitation and the formulas and that kind of thing. So just click on states, all right? And what you're going to do is you're going to use this box up here and you're going to basically compare neon to water. Neon to water. And first, just take a look at neon in a solid form. And you can see each of these little dots represents an atom of neon. And then you can look at neon in a liquid form. And I just want you to sort of pay attention to the bounciness, sort of the movement. We call that kinetic energy, the amount of movement and vibration and the way the molecules are bouncing off each other. Liquid and then in a gas. And you can see the molecules are all bouncing up all over the place. All right. And then you click on water and you look at it as a solid. All right. So notice water as a solid and think about how tightly packed water is, all right, in liquid, right? Interesting thing about water, okay, you see how it's a liquid here. The molecules are very tightly packed, but as a solid, there's a little more space between the molecules. And think about it, right? Which is less dense, right? Does water float or does ice, this is ice here, does ice float or does ice sink? Look at the density of the atoms of the molecules. Okay, and then again, click on the gas, and you can see how the atoms are bouncing all over the place. Okay, so the key thing to pay attention to is sort of the how much movement and how sort of active and how much bouncy kind of uh, qualities do the molecules have as they bounce around off of each other. All right, and you can look at ice. And then the last thing you'll do is sort of heat it up. Okay. And you can watch. Okay. And as you're heating it, you can look up here at the temperature, and you can see the temperature and you can see what happens to the kinetic energy and the movement of the atoms as you apply more heat. So heat is just there's you're adding something that makes the molecules move more. It gives them a little bit more of this kinetic energy. They're a little more active. They're bouncing around a little bit more. And then here's your temperature readout. Okay. And you can do the same thing to neon. You can start neon out as a solid. The atoms are tightly packed. And then you can add heat. And you can see as the atoms bounce around more, all right, as the atoms bounce around more, you can see what's happening to the temperature, all right? So when we think about temperature, we're thinking about the average amount of movement, the average amount of kinetic energy in the in the system, okay, in the box here among all the neon atoms, all right? So I'm going to ask you guys a few questions on Schoology, but go ahead and click around like I did here. Just compare water and neon. You can compare the other uh, atoms too if you like. It's sort of the same story. So if you just want to compare neon versus water, that'd be great. All right. And I'll talk to you guys soon.